Inverse functions. In order for a function to have an inverse, it must be one-to-one. An inverse, if f of x is a one-to-one function whose ordered pairs are in the form xy, then its inverse function f to the negative 1 of x is the set of ordered pairs yx. So, if you think about it this way, we have these items right here. So let's look at the domain and range. The domain is 0, 1, 2, 3, so it's a function. The range is 3, 5, 7, 9, all different numbers, so it is one-to-one. This is a quick way to say one-to-one. So the domain of this function, as it stands, 0, 1, 2, 3, the range is 3, 5, 7, 9. When we take the inverse function, the range becomes the domain and the domain becomes the range. That's why it has to be one-to-one in order to have an inverse, because if your range becomes the domain and it's not one-to-one, then your domain is going to have multiple items in it that repeat, and that's going to mean it's not a function. So our inverse domain is the range of the original function. The range is the domain of the original function. And that is our answer for problem 9. Go ahead and pause the video, work this out for problem 10. Welcome back. We are going to take a look at problem 11 here. Graph on the same coordinate system the inverse of the one-to-one function shown. So how do we do this? Well, all of our y's become x's. All of our x's become y's. So let's take a look at this. Let's take a look at a few of the points here. Look at this point. I'm gonna use red. It's a little bit easier to see. So we have the point -5, -3. And this little line segment before it jolts ends here at -3, -1. So to have the inverse of these points, we now have to look at, I'll change colors. The inverse is going to be -3, -5 to -1, -3. So where does that land? Let's look. So 1, 2, 3, 1, 2, 3, 4, 5. There's our new point. -1, -3, -1, then down 1, 2, 3. So that is that one line segment. Let's look at our next line segment. It goes from -3, -1 to -1, 0. So our next point on our inverse is going to be flipped around. It's going to be 0, -1. So x is 0, y is -1. It's going to be right here. Now let's look at our next point in the next little line segment. We have x is 0, y is 2. So in our inverse, we got to flip those around. X is 2 and y is 0. So x is 2, y is 0. It's going to be right there. Our final little line segment is at x is 3, y is 4. So our inverse has to flip those two around. It's going to be 4, 3. 4 up 3. It's going to be right there. So that is our inverse graph. Now, if you look at this closely, you will see that it is a mirror reflection of this line right here. This blue line, that line represents x equals y. So when you are graphing your inverse, it should flip over this line. It should be a mirror image. So take a moment, try graphing problem 12, and we'll see how you do. Make sure you end up with a mirror image of what you currently are seeing. All right, let's look at more practical uses of inverse functions, like how to find an inverse function. So f to the negative 1 of f of x equals x. So that's saying whatever you put in to f of x, if you put that into the inverse of that function, you'll get that same input again. So when we are trying to find an inverse function, we are going to be putting y in for f of x, then changing the two variables around, so y turns into x turns into y, then solve for y. Then you can substitute f to the negative 1 of x, which means the inverse, for y. And then verify that the functions are inverses by putting a number in and making sure you get the same number out when you put it into the inverse. We'll do a few examples. I know saying that out loud is a bit confusing. So our first step, we're going to put y in for f of x. Then we're going to flip our x and y around. Our x is going to become the y, and our y is going to become the x. Then we solve for y. So we got to get y on one side, everything else on the other side. So the first thing we got to do is get rid of that 7. Then we'll divide both sides by 4. And we get x minus 7 over 4 equals y. And then our final step is to substitute in f to the negative 1 of x, the inverse of f of x, equals x minus 7 over 4, and there's your answer. Then we check our answer. So we could plug a number into f of x, and then plug that number in here to make sure it comes out. But in order to be absolutely sure, we'd have to plug in every number. So instead, what we're going to do is we are going to use what we learned when we did compound fractions, and we're going to put f to the negative 1x in as x for f of x. So we're going to do f of f to the negative 1 of x. And we should get x as our answer. So f, let me try that again. We have 4 times f to the negative 1, or the inverse of f of x, plus 7. That equals 4 times x minus 7 over 4 plus 7. See, I just plugged this in right there. Now we'll simplify. 4 times 1 over 4, those are going to cancel out. So we're going to get x minus 7 plus 7. These cancel out, and we get x. That's exactly what we wanted. So this is truly the inverse function. We did it correctly. Let's look at a bit of a trickier one. We have a fifth root. We haven't even talked about fifth roots much. It's kind of gross. All right, let's plug our y in there. So y equals the fifth root 2x minus 3. Now we switch our x and our y around, so y becomes x and x becomes y. So what is the opposite of a fifth root? We will take both sides and put them to the fifth. So I'll go up here. So we'll have x to the fifth equals 2y minus 3. Get rid of that 3. We'll add 3 to both sides. Divide both sides by 2. Remember to divide that 3 by 2 as well. And now we put in our inverse notation. And now we verify. So we are going to do f of the inverse of f of x. So we have the fifth root of 2 times f to the negative 1 of x minus 3. That is the fifth root of x to the fifth plus 3 over 2. All of that is times 2 minus 3. That 2 is going to cancel out, which is the fifth root of x to the fifth plus 3 minus 3. That's going to cancel out. So we're going to have the fifth root of x to the fifth, which is x. That checks out. This is truly our solution. So at this point, you should be able to work on problem 14, and we'll come back in our next video. We'll talk about systems of linear equations.